Assalamualaikum. We are from Group 1, Section 4, BFC21002, Construction Engineering, under Dr. Nick Muhadzaini bin Nixon. In this video, we are going to present our project topic which is soil investigation, site clearing and earthwork. The group member we have is Long Naps and Muhammad Helmi bin Abdul Samad, and thirdly Abdul Khalik bin Alauddin, and fourthly is Sharmimi bin Garden, and lastly is Muad Ikwan Hazik. For a list of content presentation, we're going to talk about the definition of site soil investigation. Secondly is method of site and soil. Thirdly is path of site and soil investigation. And fourthly is earthwork, and after that is site clearing and excavation and compaction and transport and moving, and lastly is for sloping. What is site investigation? Site investigation is the process of researching a potential construction site to compile, assess, and present information on the location. Secondly, the information acquired is then used to create a report outlining the site topography, soil and rock properties, and physical ground condition and potential hazard. And lastly, the main stage of site research include reconnaissance, data and map analysis, and extensive or intensive site investigation and laboratory testing.
1.2 Method of site and soil. First, site reconnaissance is looking over area, studying the trend and determine the state, soil and groundwater. The second is purpose of site exploring. First, the sequence of event. Second, the soil, rock and qualities and natural characteristics. Third, groundwater location and variation. The third is planning soil exploration. First, what type of subsoil. Second, type of building. Third, the structure is crucial. And the fourth is method of exploration. First, open excavation. Second, boring, surface sounding, and geographic method. 1.2.4 Method of soil exploration. First is open excavation. It's be dug between 2 and 5 meter. And second, it's allowed to easy visual and investigate the various production of layers, and a technique that chunk sampling used to be removed even undisturbed soil sample. And second is boring method. For boring method, there are two drilling hole and observing cutting as they emerge from various depth. And second is lifting soil sample from the various depth using sampler. As the example of sampler is egg boring, shell and egg boring, wash boring, precision boring, and rotary boring. For the third is subsurface sounding. It's come from SPT, standard penetration test, and cone penetration test, or called such as Dutch cone test. And the fourth is geographical method, electric resistant method, semi refraction method. 1.3 Path of site and soil investigation. A soil survey consists 3 parts. First part is the priority to design is phase study days. The second is complete during the design days is preliminary reconnaissance, or being called such as a site visit. The third part is complete during the construction process. The phase 3 is detailed soil exploration, and for unforeseen circumstances, the second and third part are required. For the fourth part is write a report.
Land clearance is the most effective way to prepare a place for development. Large trees, stumps, roots, and other debris are removed from a piece of land through the process of land clearing. This enables builders to continue the process of creating a new office building, a housing development, and a road. To remove trees, stumps, and other waste from the land, heavy equipment like bulldozers, cranes, and backhoes are used. while also taking precaution to reduce the project's negative environment effects. The influence on local fauna have been minimized. Workers can begin preparing the land for development. Is recovered after ground has been cleared. There are 4 different excavations have applied in these projects. Topsoil excavation, as implied by the name, this kind of excavation entails the removal of the exposed of highest portion of earth's surface. Rock soil excavation, to get rid of the construction barriers like stone surfaces, this form of excavation is used. Mud excavation. Mud, a mixture of soil and water, is frequently ugly and needs to be removed during construction. Earthwork excavation. Earth excavation for building involves removing soil or the layer below the topsoil. During the technique, wide and shallow layers of topsoil, pebbles, sands, and other unwatered materials must be removed. The technique also includes grading the land. Trench excavation. Trench excavation is frequently used for this project foundation, sewer system service lines, and pipelines. This method of excavation have been used to dig shallow trenches up to 6 meters deep. Dredging technique of excavating and removing underwater sediments and debris to make way for construction needs. Thank you.
Assalamualaikum, hello, my name is Muhammad Alvin bin Samad. My method number CF220007. I will present one of method in earthwork construction, which is compaction. What is compaction? Compaction is the process of increasing the density of a soil by packing the particles closer together through the application of external force. Compaction cannot be effectively achieved by track machinery as track distribute the load over a wider area, effectively minimizing compaction. Compaction process for cohesive soil. Compaction of cohesive soil is achieved by impact and weight to break down the cohesive bond to increase the soil density. Needing compactor with high point loads such as sheep and pet food roller are required for cohesive soil. The strength of cohesive soil is influenced by moisture content. Compaction process for granular soil. Compaction of granular soil can be carried out with static compactor that simply apply weight and tend to compact from the bottom of the layer up. Vibratory compactor that use a mechanical action to consolidate soil particle. Impact compactor that use high amplitude weight to compact material. Granular fields are usually suitable for field construction as strength is usually adequate over a range of moisture conditions. The purpose of compaction: first, increase bearing capacity. Second, reduce compressibility. Third, reduce permeability. Fourth, improve stability. Fifth, heavy or highway VS building foundation compaction operation. Now I will discuss about the factor affecting compaction. First, moisture content. To achieve the desired density of the soil, the moisture content of the soil has to be controlled properly. If the water content is low, it leads to soil being stiff, which resists compaction. When the water content is increased, lubrication takes place between the soil particle and the soil become more workable. Second, type of soil. The soil type influences the compaction of that soil to a great extent. The coarse-grained soil can be compacted to higher dry density than the fine-grained soil. The maximum dry density decrease of the quantity of fine is increased to an amount more than that required to fill void in the coarse-grained soil. Hence, it is safe to say a well-graded soil obtains a much higher dry density than a poorly graded soil. Third, amount of compaction. The optimum water content required for compaction decreases with an increase in the compaction effort. This effect of increase in compaction is significant only until the water content reaches its optimum level. After that, the volume of a void becomes almost constant and the effect of increased compaction is not significant. Fourth, contact pressure. Contact pressure is the pressure between the soil and wheel of the equipment used for compaction. This pressure depends on the weight of the roller, wheel and the contact area. The higher contact pressure increases the dry density and lower the optimum moisture content. Fifth, speed of rolling. There are two important things to be considered. The first, the higher the speed of rolling, the more length of embankment can be compact in a day. Second, the higher speed of rolling, there is likely a change of insufficient time required for the deformation to take place and hence more passes may be required to achieve the desired compaction. There are 7 types compaction equipment. First, stamping foot roller, grid or mesh roller, vibrating compactor, steel wheel or smooth steel drum roller, rubber tire or pneumatic roller, segmented pad roller, tempers or hammers. There are 5 methods of compaction. First, static weight. Static pressure is the most form of compaction. Virtually all objects exert some degree of static pressure compaction. The greater a particular weight, the more static pressure it will exert. Second, impact. Both static pressure and manipulation harness the power of gravity to accomplish a compaction. Impact compaction takes a more proactive approach. Here, the compactor literally hits the surface of the ground. This contact increases the amount of force it exerts. It also sends a localized pressure wave straight down into the ground. Third, vibration. Vibration force are closely related to impact force. In fact, the two can be easily confused, where impact compaction involves force that moves straight down. Vibration compaction consists of pressure wave that spread out through the ground in all directions. Fourth, manipulation or kneading. Manipulation, also sometimes referred to as kneading, act to compress material at a greater depth. It does so by reducing the surface area at each particular point of action. This enables the compactor to exert a more localized and hence greater amount of force in each particular area. Finally, percolation. The concept of percolation theory are used to elucidate the formation of a table by compression of particular matter. The process of compaction can be considered as a combination of side and bond percolation phenomena. Because of the effect of different particle size and shape of the particle in the powder bed and effect of little fracture and plastic flow, moisture content of the powder and finite size of the tablet, no sharp percolation threshold are expected.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Khalid bin Alauddin. I am from Group 1. I will explain about transportation and moving. Earthwork is something that transportation projects seldom avoid. Earthwork is expressed in units of volumes. Increase in such volumes require additional trucks, which cost more money. Heavy machinery is known as earth-moving equipment. It is important for designers to engineer roads that require very little earthwork. Next is importance of transport and moving. Firstly is to carry heavy machineries to construction site. Next is delivering necessary construction supplies to job site on time. Furthermore, it is to move debris during the clean-up phase. Lastly is for material handling or equipment transportation. There are a few types of transportation, such as tipper trucks for dumping large quantities of load material. Secondly, trailer trucks for hauling equipment supplies long distance. There is also tanker, which for transporting materials on highway and through job sites. And lastly, dump trucks, which for quickly hauling and dumping their loads. Moving on to sloping. A sloped ground floor surface, whether created naturally or artificially, is referred to as a slope. Civil and mining engineering projects usually include heavy demolition and excavation activities that lead to the formation of excavated rock slopes. It is essential to maintain the stability of these slopes till the end of the design life for the successful delivery of a project. The importance of sloping is as such. Firstly is to stabilize an unstable or inadequately stable slope. Secondly is there could be slope failure or landslide if the stability conditions are not met. And thirdly is to eliminate points of concentrated flow using slope drains as outlets. There is 3 types of slope stabilization methods. Method number 1 is geometrical techniques, which includes flattening the slope or eliminating part of the soil or rock, as well as recompaction of slip debris to provide more resistance against loading. Next is hydrological techniques, which requires installing surface and subsurface drain pipes and therefore reducing pore water pressure or the use of thermal techniques such as ground freezing and heating methods. Lastly is chemical and mechanical techniques, which is using grouting to increase the shear resistance of slopes and by planting shrubs and grasses to reduce soil erosion. There are also many stabilization strategies to reduce slope failure, one of them being providing drain pipes and drain holes or use of dowel bars. Also, installing rock anchor and flattening of overburden slope could reduce slope failure. Last but not least, constructing concrete or masonry walls with whip holes could also excessively improve slope stability. Thank you very much.